Laminar flow. The flow where layers of adjacent fluid slide over each other. Streamlines are straight, flow near wall slower than center. Example, honey falling off spoon. Turbulent flow. The flow where particle paths are irregular and chaotic. Large scale mixing. Flow in radial direction. Example, smoke from chimney. Transitional flow. In most applications, the flow will not remain as either laminar or turbulent, but it transitions between the two. The transition point is related to the fluid velocity, length scale, fluid density, and viscosity. This is Reynolds number, given by the equation rho c d by mu, where rho is the fluid density, c is the fluid velocity, d is the length scale, normally pipe diameter, and mu is the viscosity. This video shows how dye changes in a pipe with increasing Reynolds number, that is, a transitional flow from laminar to turbulent. Fluid viscosity. There is a shear force associated due to the relative motion of layers of fluid. The magnitude of this shear force is due to the fluid viscosity, given by the equation τ is equal to mu dc by dy. For most applications, the variation of shear force with change in velocity is linear or Newtonian. Fluid viscosity. Viscosity is generally independent of pressure but strongly dependent on temperature. There are two ways of defining viscosity: dynamic or absolute viscosity and kinematic viscosity. Kinematic viscosity is defined as a ratio of dynamic viscosity to the density of the fluid. Laminar or turbulent. The flow regime is defined by the Reynolds number. If the approximate Reynolds number is less than 2000, the flow is laminar. If the approximate Reynolds number is in between 2000 to 3000, the flow is critical. If the approximate Reynolds number is greater than 3000, the flow is partially or fully turbulent. A question for you. Oil of density 810 kg per meter cube and dynamic viscosity 0.165 pascal second flows through a 20 mm pipe at 15 meter per second. Is the flow A, laminar, B, turbulent, C, in the critical region? The flow regime is defined by the Reynolds number. Reynolds number is 810 times 15 times 20 times 10 to the power of minus 3, that is converting millimeters to meters, divided by 0.165, which gives the answer of 1470. Since the Reynolds number is less than 2000, the flow is laminar.